Hi, everybody. My name is Jim Hassman. I'll be your host today for the webinar. The topic we're going to be covering is designing for extreme environments, specifically longevity for extreme environments. I'm the president and chief revenue officer of Blues and have been with the company for just over 4 years now and have spent my entire career, the last 25 years, working in predominantly in enterprise software and AI for about 12 years of that. And would like to introduce our guest here today, and then I'll give you a quick intro. Actually, let me do this. Let me give you a quick intro of Blues first, and then I will introduce our guest, and we can get into the topic area. So, for those of you who this might be your first exposure to blues, you might be asking yourself, what is blues? What does blues do? I'll just share real quick a couple of things that'll help you, and then we'll get into the topic for today. So, Blues is um, a software company, believe it or not. And you might be thinking, well, I thought you guys had some hardware, and we do. We have hardware. I'll cover that in a second. But Blues is a software company. And the hardware that we have is a little device called a note card. And there are several versions or flavors of the note card with different kinds of radios. I'll show those in a second. The software is called Note Hub. But when you think of what Blues offers as its product, I need you all to think of it as a system. The note card is part of the system. The data flow from the device to Note Hub and to your end application is part of the system. The ability to manage and scale a fleet of devices or many fleets of devices across different projects is part of the system. So Note Card and Note Hub are the Blues product together. They are not, you cannot isolate them and use them one or the other. They are tightly integrated by design, predominantly for optimization features of moving data to and from the device, updating firmware, and probably the most important architectural reason they are tightly integrated is for security. So this is the little blue box in the middle is a representation of blues. The little icon on the left is a depiction of a note card. The little cloud icon is a depiction of Note Hub. Over on the far left, we support all kinds of products across every industry vertical, industrial, commercial, um, products, energy related, environmental related, medical related, transportation, logistics related, all kinds of products. In fact, we're going to be showcasing many of these at the CES show again this year in Las Vegas in January. So you can come check out the showcase. And over on the far right is you. You're wanting to take information from these edge devices and turn it into a service that helps your downstream customers and users of your product gain value from your solution by connecting these things and providing intelligent services that move back and forth across these technologies. Our whole design is to make this simple, to make it easy, to make it cost effective, where you can buy one to go try something, or you can buy tens of thousands, hundreds of thousands, and the business model will scale with your scale. This is not a company that built something for people just to prototype with. We built the solution to help people scale commercially. These are the note cards. We're constantly coming out with new ones, but this will give you a good overview of the types of radios we support. Cellular, we have a hybrid one that has cell plus Wi-Fi. We've got a Wi-Fi only one. We've got a LoRa version, and we have satellite. If you notice the bottom connectors here, these are all an M2 based connectors, so these are plug and play. What does that mean? It means I can, if I have a cellular note card in a device and I would rather use satellite, I can pop in the satellite note card and not have to make any firmware changes. They literally are plug and play. It's a super cool, what we call multi-radio design approach. And so you can build your devices without really having to worry, like, what is the most appropriate radio for where this specific device will be deployed. A whole bunch of features. You can get all these on our website. I'll point out a few key ones that people love. On the note card specifically, they love that it comes loaded with 10 years of cellular service included in the cost of the actual hardware device. So you don't have a contract with the carrier. Obviously, there's a modem on board, there's a SIM on board, keys inserts are flashed at the point when the device is manufactured, so you don't have any key insert management. And it's 500 megabytes and or 10 years of service. If you run out of the 500, it can automatically add another 500 megabytes for you for another 10 years of service without you having to do anything. So it's super easy for people to take this solution, embed it in their product, and not have to worry about the connectivity aspects of it or the security aspects. Note Hub. Again, this is the core of the Blues product offering, the software side of this. Imagine managing devices that, depending on what they're doing, may need different types of configurations, managing firmware updates across all those devices, keeping devices from becoming bricked or shut off to the outside world, requiring a human to have to go, God forbid, out and like find the thing and put a new one in or figure out what's going on with the firmware. Note Hub allows you to manage these fleets remotely without having to send people into the field. And so Blues is not just a little module provider. We make it possible to manage the complexities that come with managing remote fleets all over the world. And it's pretty cool from our side of the world to see where devices are lighting up each and every day. They just pop up all over the world for all types of products. So Note Hub is a key aspect of the Blues offering. And I think for those of you that have used it, you realize that making configuration changes like makes your life so much easier, and doing over-the-air firmware updates. Obviously, Note Hub allows you to route the data from the device to your in-cloud application, wherever that may be, very seamlessly. And again, why do all of this with Blues? The biggest reason is to keep you from being the top line of this chart. You spin, you fix, you spin, you fix, you spin, you fix, to a point where you're just so frustrated that you can't get it to work for whatever reason. It might be a business or economic reason, it might be a technical reason, it might be adoption reason. We want you to be the bottom line, which is to get to market as quickly as possible. So that's really why Blues exists. I'll stop that little shameless plug about Blues and introduce you to Dr. James Powell, who I've known for almost 4 years now. He and I met in the UK. I think he was soldering something or coding something when I walked by and was introduced to him. But glad that he is made himself available for today's conversation. I'll let him give you a little bit of background on himself. He's currently with one of our key partners at Blues, a company called Enable IoT. And I'll let him introduce himself as well as who Enable IoT is.
Thanks ever so much, Jim, and for inviting me to join in this fireside chat this morning and go through what we're doing here at Enable IoT. As Jim said, I'm James Powell. I'm part of the team here at Enable in the UK, which is a fairly startup company. It was formed in early 2021. I got involved when Jim said he sort of met me about 4 years ago. And joined the Enable team and been responsible for developing the firmware and hardware behind the Sense 30 product. If anybody's interested in having a look, the website is enableiot.io, and we're both a hardware and software company, predominantly in the agricultural market. So at the moment we've got the Sense M30 product, which is a hardware platform which is gathering loads of information from out in the field, pretty much an intelligent weather station. And we've also got a very sophisticated, we've got our own back-end platform on the web, which is a full AI data processing system. And Enable actually started really looking at carbon capture, which is one of the real key issues at the moment, is how much carbon is being given out and captured by soil. And the whole team behind Enable came up with this proposal where looking at reading certain parameters from the soil, taking that to the cloud, and then with an AI engine processing different parameters and actually looking at how much carbon is being captured in the soil. And that's really when how the company's come along. And as Jim said, I got involved very early on looking at the hardware for this system. So where we are today, about 4 years down the line now, we've got a fully working system, which is going out to market.
Well, James and I both share a common background, and maybe some of you that are attending this call also have this background, but we both grew up in the agricultural world. My family farmed and ranched, and I can tell you, having grown up in that lifestyle, things get really dirty. It's hot, it's cold, it's dry, it's wet, it's dirty. And Enable IoT has this device called the Sense M30 device that James was briefly describing. James, can you tell us a little bit about when Enable was designing this product, some of the things that you guys put down as requirements that it needed to have in order to survive in the conditions it was going to be
Basically,
put through?
how this whole project started is when Enable IoT came to the table, and there was as I say, they got the back end software, which had been pretty much designed of what could be done processing wise, and it was presented with a small 3D printed box with a variable circuit knocked together, and it's like, we need to make this work. So it was literally pretty much a blank sheet of paper, very much, I wouldn't say proof of concept, but something that was literally sending a couple of parameters to the cloud. And it's like, how can we make this now a commercial system that we can design and manufacture and make the whole Enable ecosystem into reality? So the first stage, I'll just sort of pass through some of the stages that we went through to where we are today, was to take the original breadboard, which at the time did have a different modem into Blues. It was just really can one of the team within Enable get some of these parameters in, send it up to the cloud? Can we get that into a working PCB and just get some working initial prototype working? And that was my first task in this, was taking the breadboarded modem and a little micro on there, and to produce, and you can probably see from behind me, I've got basically vertically integrated, got all the resources. I doing design, firmware design, PCB design. We've got all the manufacturing equipment here. Was to take this original prototype and produce a working proper PCB. That started by just taking, once we've got that PCB done, into an ABS box, into a very simple system that we could say, right, we've got a working PCB, could actually go out into the field and start getting some information through. Obviously, it was literally, that was then the proof of concept, which was an ABS box, a little solar panel on the top with a pole that stuck in the field. Nothing that could be sold, but it gave us a starting point that this was the basis of the Sense M30. And if you actually look on the Enable IoT website, there are a couple of images of, well, obviously we'll look at the product in a little bit, but there's an image of a pole with what it looks like a little ABS box and a solar panel to put on the top. And that was literally the first version of this product, which had a proper PCB in it and just cobbled together with an ABS box, piece of pole from Screwfix underneath, and a solar panel. And that gave us the first system that started then getting proper data out, outside and up into the cloud. Then came the task of, this is not how you're taking this then into a proper product. And what I've got here is actually, if I see that, is the first version of what we'd say is the proper proof of concept of the product. And this was taking the whole ideas of all the different sensors we wanted to integrate into the device, and make something that was a proper product to be deployed and put on beta testing. And one thing that is interesting outside the electronics is actually the housings. And obviously we'll probably come into this in making things robust and actually bringing products to market, is actually having something that is, fit for the task, but actually looks the part and actually functions properly. And obviously, as I said, an ABS box doesn't cut the mustard, but to get to a product, in a lot of cases, you've got massive tooling costs involved. And that obviously for a startup is a no-go. So what we've done with this product is quite an interesting technology using flat sheet. And it's the intermediate step between a 3D printed product and a full injection molded product, which would typically take tens of thousands of pounds in tooling costs. And you see here, this was the first unit, which looks like, pretty much a finished product. And that is completely produced by precision machining on flat sheet plastic technology, precision machining, welding, etc. And as I say, this was then the first unit, which was the first prototype. So we put the PCB in here and then started to develop the product.
I skimmed over a bunch of the note card things earlier, but for the note card itself has a couple of features that may have been helpful to you, but I'd be curious about what you did on top of it. The note card can be shipped to you with conformal coating. Obviously, electronics don't like moisture, so getting these things conformal coated if they're going to be in an environment that might have moisture is helpful. And then when the device is at idle, at kind of a steady state, these things are extremely power efficient, only drawing 8 microamps or 8 nanoamps of power at idle. But on top of that, what did you do with your enclosure to make it, I would say, weatherproof? It's going to be subjected to
That, to be
elements.
honest, was
And
the
then the
key
batteries,
feature.
what did you do on the
Yeah,
power side to get?
easy with everything. Obviously, on the enclosure, is we came up with a concept, with the whole team around the bench, is what we wanted to see of the product. And this was, let's say, the concept that we came up with. We then, as I say, we made the PCB in and deployed it in the field. And it was really a case then of looking at how this performed. It was literally a proof of concept to get something out to start with. And it was actually when we started making these in probably the multiples of 10 that we then started realizing, and the design process started, because until you get something out there, looking at IP ratings, temperature, conformal coating, etc., is how this product then evolved. That we did end up going back how there was quite a lot of issues with this. Let's say you can have the great ideas in paper, put it out in the field, and then start getting some actual data through. So we started off with a battery, which we thought again was applicable to the solution, with a solar 1 watt solar panel on here. Obviously with the Blues note card, started then getting data from this system, and there was no end of things that we were then learning from this initial concept. Was power requirements, and that was actually one of the first things that really was the barrier to this product. Was we're not just picking up one parameter from a little sensor and sending it to the cloud every day. Because of what was needed for the AI backend, we've got multiple sensors, and hence in the word Sense M30 was to pick up, was to actually capture the data every 30 minutes. So we've got, in a way, some quite power hungry sensors strapped onto the system. We've got a 30-minute reporting time and a small solar battery. And that was one of the first things we found, that given all the parameters, or the checklist for the product, was that we weren't getting enough solar charging throughout the day. The batteries were depleting very, very quickly. And actually the power management was one of the key issues with this product, taking it forward, which was found by literally having, let's say, about 30 of these units out in the field, different locations. And again, you can't, for this type of application, which is solar powered, you can't guarantee that when it's deployed, it's always facing south. It might get, somebody will deploy it in the field at a slightly different angle, so you're not getting good solar capture. So it was just getting in actual real world, because you can go through the data in the lab a bit, and a bit like new modern electric cars, they give a certain range, an ideal, but in practice it's nowhere near that. And what we thought originally, with a given solar panel, with a given battery capacity, the electronics in there, what sensor we're having, where we would be, and in reality we were nowhere near. Real time, getting out in the field and getting some real time data in real weather conditions was the key driving point, in taking it to the next stage of development.
So you went from this situation of like power draw is happening much quicker than you anticipated. You may or may not be getting the charge cycle on the solar side. Where are you at today? Like fast forward all the way to today. Like, what's the power story today? Like, what are you using, and what's the performance you're getting out of the device?
Well, that was, to say, that was the first unit, which was used for the trials. This now, again, if you look at the website, is where we are at now with the product. And this now is production ready. Still, again, housing wise, still using the same flat sheet technology. As you can see, it's a finished product. Um, Obviously, much bigger solar panel, much bigger battery pack, and a lot of work involved in the electronics internally in terms of power management. And this product now has, as I say, we've had pretty much a year now of full testing, and the batteries are not dipping at all. We're literally keeping the batteries fully charged. One of the key things, which we are still gathering data, it's a fairly new product, is going into the winter months now, when obviously the days are getting shorter, is optimizing that. But it's something that, given the electronics in there now, which gives us a lot of flexibility, because we've not just got a single fixed firmware architecture in there that says this product has to do, is, as we say, we're collecting data every 30 minutes. In an ideal world, we transmit that to the cloud every 30 minutes. But obviously, the key thing is actually the power draw as well, and on the cellular communications. And certainly where these products get located in fields, quite often the cellular coverage is quite low. So obviously that then does vastly increase the power draws when you're trying to connect to cellular. And obviously what the Blues platform has given us with this electronics now is complete and utter flexibility, that if this now was in an environment, we could set that to gather data and transmit every minute, but we can actually adapt it automatically, that if we see that the battery is during winter months is actually starting to decrease, we can use the functionality within the firmware of our processor and also within the Blues note card architecture to adjust how often, obviously we're collating the data, storing it, and how often we then transmit to the cloud. So the system now, from literally being transmit every 30 minutes and cross your fingers, we've now got a lot of intelligence built in there in terms of power management, battery management, that if, for instance, it is in very low light levels for a vast amount of time, it goes into ultra low sleep mode, just wakes up and still take the readings, doesn't do any cellular coverage, and then we can just dump all that to the cloud in one connection, and we're doing that now fully automatic, so everything can adjust given the parameters. And that has taken the testing period from over a couple of years to get that absolutely nailed now, to where we're at with a product that is performing fantastically now. We are so happy with where we are. And as I say, it has been a real mix of power management within the note card, and also we're using an STM32 ultra low power micro in there.
There's you said something in there that I want to draw out, because it's something that I didn't know when I started Blues, but I've heard it enough times now where I think there's a real legitimate there. You talked about being able to update the configuration remotely. Um, I've heard this over and over and over again from customers that use Blues. There's so many things about the simplicity of the note card and the ability to route data that obviously people love. The fact that it comes with cellular connectivity built in, they don't have to worry about. They love all that. But I said, if you had to pick one feature that literally changed your life, what would it be? And a lot of them go to this remote configuration
I
update.
think it's the ease of the platform is
Yeah.
what Blues actually brings as a developer. Um, is just the ecosystem from what Blues offers um, as the radio device, so the connectivity within the product, but also the back end and the features that the note card specifically has. The fact that you've got the system built in for doing remote updates of our processor that's in there, that's embedded within the Blues system. And I actually used that last night. We sent one of these products out as a demo. Now, obviously, this product normally reports every 30 minutes, but literally in 2 seconds, I could go onto I could just compile a new piece of code, send that to the cloud, click a button, and within 2 minutes that was downloaded. And I was running new test firmware specific for a customer, so they could actually have some quicker streaming, a little bit more customized. But that was just done, within a few clicks in a couple of minutes. And
Wow.
having that flexibility and that ecosystem and how it works, the time involved in having to do that ourselves. As I say, we've actually got, it's one of the key parts of Enable is the we've got our own back end and webs uh, front end for all the data analytics, but having the Blues architecture to manage the firmware and actually talking to devices and doing that in terms of time to market is phenomenal, because to actually if we'd have had to do that ourselves with another modem and integrate that into our web system, that would have taken, the time to market would have just been vastly uh, increased.
Yeah, for sure. Um, I want to get into a little bit of the development and testing approach topics. I know we have some engineers on the call. We have actually a broad mix of people today. We have product people, we have engineers, we have some business people and salespeople from their companies. But this will take more of a slant on, okay, you produce this thing, you say it's production ready, but take us through the logic that you had of designing something for the ease of service, the ease of installation. And we see this across all the various products that people are using Blues for. But a lot of times people design a product in, like you said, a lab setting. And they go out and they test it and they know everything about this thing. And then they get to a point where, okay, this works really well. And they're getting ready to ship it to the field. And now there's these other people downstream. They're going to be interacting with the device. So we're not the engineers that built it. We got people that will be doing installs and support and sales and servicing. How do you think about the design of that device specifically as it relates to the service and the installation process as this product continues to scale into market?
Well, actually, that was one thing that, given this product here, the first thing in terms of installation and servicing, and actually IP ratings. It's one of the things we did find, not only the power draw, but actually making a product that, if does actually have to be opened up in the field, can be sealed up again. And in the years I've been developing electronic products, that's been one of the key things I've found. It's just, you can have IP products, and as soon as they've been opened, once they go out in the field, they never get sealed up again properly, and you get water in.
Mm-hmm.
And that's one of the things we did start in the early process of conformally coating all the boards uh, to mitigate that effect. But in this design, it was literally the case of, just how the product went together. I think, and you don't see that quite often, is a team looking on the bench until you've gone out there. We've worked with some installers. They've realized, for instance, that, certainly when you're doing prototyping, you might want to change a board over or do something, change a connector, and you can't get into the product, or once it's open, you can't seal it back up again. And that was, again, electronics aside, was one of the key things with this first prototype, and part of the learning process, that not having a product that's like a sieve, that's, lets water
Right.
in, it is non-serviceable. And I think, that's one thing that, quite often designers don't see, and in my career, you do it in the bench, you understand what you're doing, you subconsciously put things back together because you know it needs to go right. When it goes out in the field, and certainly in the farming, in agriculture, it's a very, very harsh environment, and it's just complete doesn't equate to what you see in the lab. And that's where, we are here, with this version now. A lot of the things, serviceability, you just couldn't, you couldn't hardly take the circuit board out of there. One of the design constraints was to make the products as small as possible. It's no good making it small if you need tweezers and microscope to actually take it apart and service it. So hence this is, where it's evolved to here now, where we've actually got this whole module just with 4 screws, drops out. You've got a full chassis. You've no real wiring looms apart from that. So all the connectivity on the base of the unit here is all within one module that drops out. So serviceability, 4 screws straight
Mhm.
in. And obviously, you've got to get in there. But in terms of putting the product back together, it's a lot better. It's far easier now to make sure that product goes back together in the field and is properly sealed.
Yeah.
And just that actually the opening is underneath and not round the whole product, which was before. And all these little things have just all come together to make, a very, very robust product from design iterations on the hardware.
Yeah, so I think the takeaway here for people joining is that there's definitely some wisdom in not just design requirements for the product, but requirements for the installation process and serviceability in the field. Because if that gets overlooked, a lot of times you're back to the drawing board trying to refactor things. I'm watching a project right now where they are running into complexities in the install, and it's because they rushed into design of the product and didn't think through install. Um, and so anyway, um, the lab testing versus the real world performance is something you mentioned a couple times in here in this conversation. The calculations that you're doing on the data when you begin are theoretical. What's your approach with this device as it relates to doing field validation? And what surprises or interesting things have you encountered or learned?
Specifically on the power management side, I think it is really more the deployment aspect, because obviously we've got the kit in the lab, the sophisticated analysis. So for the raw circuit board, so it can run tests in the lab, look exactly how much power draw is being drawn exactly. But the key thing with this product as well is that we're actually opening it up, and what we're finding, as we're talking to more customers, it's not just for agriculture, and we're finding other uses. And being a multi-sensor, it's not just we've got a product that has a specific sensor in there. We're actually adding other sensors to the product, which affects the power requirements. So again, it's not just we've got a fixed system that we're working to. And actually, it's one thing actively we're involved with now is incorporating some more water sensors into the product due to some more applications, and they're affecting the power as well. So it is a little bit varied. The fact that it isn't just a specific product with a specific sensor, and we can do all the calculation on that. We're making it as flexible as possible. And I think that's where, coming back to what I said before, of having the ability to, in real time or remotely, change the parameters of reporting and shutdowns, etc., etc. So we can adjust for different sensors in that. As I say, going back, the raw circuit boards in the lab with all the sensors connected, linked up to power analysis equipment, gives us a very accurate amount of how much power is being used against battery life. But again, it's really been key in the field is optimizing the solar panel, and getting that, as I say, getting all of those parameters working together.
Yeah,
Um,
we've got a little bit of time to do questions, so I want to switch into that because we're fortunate to get a bunch of questions submitted in advance of this. We'll get through as many as we can, and then there are several that have come in through the Q&A chat in the Zoom. So if we don't get to your question, because there are a lot here, folks, uh, I will give you guys my email address. Um, we can correspond. I can get you in touch with our field application engineers if it's a deeply technical question, but we'll try to respond to everybody as we can. First question, and James, we'll probably have to be somewhat brief to kind of get through these because we could take any one of these topics for a while. We are developing a medical device that will be worn for 2 to 3 years, up to 18 hours per day by adolescents. We need it to tolerate being dropped, exposed to rain and sweat, and have an extended battery life. What do you think is the most challenging aspect of designing a device like this?
Well, obviously, that's not going to have a solar panel on it. So it's very, very, and that's one of the things that all these semiconductor manufacturers now, it's all going ultra low power. And every week the micro manufacturers are bringing out new variations of chips with, going down to micro nanoamps of standby power. And that is, I would say, probably one of the hardest tasks. Is certainly, we've got the luxury here of being able to charge, with a solar panel, something that, and I'm actually involved with some other projects at the moment, which are literally just battery powered internally, which, yes, you're having to make sure that, the people are expecting 5-year lives out of it. And the key thing is power management within the IC. Obviously, Blues is great because there are shutdown modes and sleep modes once you've sent the data to note card and up to the cloud. But obviously, with if you're using a Blues note card, you've got some other processor running your application, and without a shadow of a doubt, it's the software skills and design. I would say, that's where I would say a vast proportion of my time has been spent on this product, is actually optimizing the power management within the chip. And certainly, like we're using an operating system in there, and actually getting all the operating system working and all the software properly shutting down, and actually having, as an R&D, having the right kit so you see exactly what's going on. And I say, technically having some, precision power analyzer systems is invaluable in terms of developing this. I just couldn't have done what I've done without having that sort of kit, because you need to be, for that sort of product, looking at microamps of standby current, and that is only just by very, very good, not only firmware but also what hardware. And some of the things I've had on this, where you put in some of the power, the power supply management that you've got in there from the power supply ICs, that again, the data on the data sheets is not what you find in real life, that they might say 100 microamps and you're actually getting 200 microamps, and it's where it's going. And just minor little things can make such an impact and just absolutely wallop the battery life in these products.
Yeah, I think I'm not a professional product designer, but watching some of the products that have been built with Blues that are subjected daily to extreme vibration environments, and we have one that gets mounted on the chassis of Class 8 semi truck, and these things are driving, and there's the some of them are off road, some are on road. Um, you can, I don't think the most challenging aspect is designing shock absorption. That can be done in a variety of ways. I actually do think it's, in terms of the battery and the power management life, if you're needing this to go 18 hours a day, it is really looking at um, the activity that is going on from the sensors to your host MCU to the note card to note hub. What does that traffic look like? Are you waking the note card up and putting it back to sleep? Are you leaving it on all the time? These are the things that actually chew through battery fairly quickly. And so as you get into that, Blues offers what we call a min spin review. And some of you may have used that service, but it's basically meeting with our engineers to look at your design and help you optimize, based on your design and your architecture and your requirements, how to get the most out of things like power, how to get the most out of antenna placement and selection, so that your RF is working the right way, you're optimized for power consumption in the best way possible, and you're not banging your head against the wall only to realize like down the road you call us and say, hey, I just can't get this thing to work, and you've been working on it for 6 months. We probably could have helped you 6 months before. So don't hesitate to use our Minspin um, um, review service that we offer at Blues. It's we don't charge for that. We just want to prevent unnecessary spends. Next question. What recommendations do speakers have for underwater environments and communication between nodes in harsh environments, high salinity, waterproof, low temperatures? James, I'll let you take the first crack.
I don't know about underwater. As I say, this is not designed for underwater, but it's IP67. It does go in probably some of the most harsh environments in the middle of fields, getting run over by tractors. Um, Again, rigidity, the strength of this product, how it's being designed mechanically, but also connectivity wise. I think we're on the one of the third variation of one of the charging ports on here, because again, everything just gets covered in mud. Uh, and you might have a connector that looks okay, but if it's not properly sealed or got the right caps on it, again, there's lots of IP connectors that's used on phones. You think, oh yeah, use one of those on an outdoor product. Use that on here, and it would just be useless. So critical choice of IO connectors, for harsh environments again is key, I think, on this.
I'll just make a plug for a Blues customer who actually has built a product that is subjected to all of these things. It's a company called So Far Ocean, and they make these yellow buoys that they've dropped. I think they're in every ocean around the world, and they're monitoring waveforms, current, temperature, barometric pressure, and they use the data for all kinds of things: hurricane prediction, optimizing shipping routes and shipping lanes. But those devices were designed specifically for this environment you talk about. So you might want to take a look at that. If you have further questions, maybe some of their approaches, feel free to get in touch with us. But there are Blues products out there, powered by Blues products out there that are subjected to all of these things. We are almost right at time. I'm gonna do one more question here, and I'll take it from the not from the pre-submitted questions, but from the open questions here. Um, okay. This one would be for you, James. What type of batteries are you using, and how are you managing potential extreme heat and cold?
We are using lithium-ion packs in here, which say so far, we've got temperature systems in here, which will prevent charging and discharge depending on temperature. So that's managed. Yeah, so again, it's part of the system in terms of temperature management within the system, stopping charging if things are too hot. Certainly, if this is in the sun and the internal temperature just get too hot, things will stop down and automatically shut down. So there's this intelligence built into the product. It's not just relying on the actual pack itself for charging. But to say, so far with with what we've got in here, we've not seen any battery issues.
Great. All right. Well, the time went really quick today. I'm going to have all of the questions extracted by our team, and we will try to get answers back to everybody here because I want to make sure everybody's questions do get answered. Some great questions in the chat. Thank you.
Yeah, well,
Whatever.
thanks,
Yeah,
Jim. It's gone very, very quickly, and if anybody has got, it's difficult to cover, all the technicality in such a short time. But if anybody has got any questions, reach out to Jim, put me in, put us in touch. Quite happy to assist anybody, who's got any other further questions on what we've done and avoid any pitfalls, on this sort of design.
great. Well, thank you, everybody. I told you all I would give you my email address. So if you have a pen or a keyboard, it's really simple. It's J Hassman, HASSMAN, at blues.com. So feel free to drop me a line and we will get in touch with you. Thank you, James, Dr. James Powell, for your
No,
time
thanks ever
today.
so much, and
Yeah, this has been a long time coming to be able to get you on one of these. So I appreciate you doing it.
yeah.
And for all those who took time out of your schedule today, thank you as well for joining. Have a great week.
Okay, thank you. Bye.